Thank you very much, the chair and everyone for your patience. I'm in the right time. I'm in the board of directors of ISARC meeting and then rushed on time. Now, my name is Quang Phuc. I'm from University of Technology, Sydney, from Southern Hemisphere. And my presentation today is a prototypical digital twin of multi-rotor UAV control and the trajectory following. Now, the authors, including my PhD student Nguyen and Lanh and myself. In the digital twin, there are many concepts, and we try this prototype to incorporate control and planning in UAV to inspect a construction site. We know that, okay, that is the big area, but here is our approach as to how to incorporate our knowledge to customize the system in a sense that's UAV in surveying. If you listen to the plenary talk this morning, then you say construction surveying of a site is rather important, and how we can manipulate that process. Now, okay, that is an agenda of the talk, and this is the general, introduction of the project, including many phases. First is the modeling and the digital twin, which I talk today, but the project including also low-level control, because if you control a platoon or a team of UAV to do the inspection, then you need to start from the low-level control of the quadcopters or the multi-rotor vehicle, and then next is to how to deploy them in a path, total path planning, which is high-level control. Here we use cooperative path planning because we want to control not only one but multi drones, multi UAV, and then we do the inspection. So I have some digital twin imaging of that construction site and how we do that. Duplicate of this is the digital twin of a monorail bridge, and the computer program to duplicate it. The imaging can be go into next phase of deep learning in order to process the image captured by the drones. And that is our introduction of the whole project. Rather large. We just take a part, small part in digital twin to present it here. So yeah, you see that a couple of applications are there. The challenge also there, particularly the faulty cases or any faulty or any unexpected scenarios can happen to the team of UAVs. So the solution is we have to duplicate that, and the digital twin offer a tool in order to verify for the engineers or the manager to kind of predict on the possibility of incident that can happen, and then we can easily to deploy that in practice. Now, this is a multi-rotor aerial vehicle dynamics. Okay, if we notice the symmetry between them, then we can understand that everything then can be rendered via Lagrangian equations. But finally, it is the thrust that is the summation of the thrust from each rotor to lift up this helicopter. So I pose a question from my PhD student as to if there is some faulty with the rotor, one rotor, then maybe you can survive that, because if you use multi-rotor, for example, 8, then you just drop a symmetric pair of that motors and then make it surviving to at least to commit to the headquarters or to just safely protect that. And that is the motivation, one of the motivation that we use the digital twin, because you cannot just say there, just switch off one motor to do that. Okay. So basically low-level control, we previous work in order how to gain the robustness of the control system in order to make it, let's say one of the rotor you can control properly, and then you can control them in a team. And then coming up to the cooperative path planning, this is the application of game theory in order to coordinate the team in order to execute a robotic task. We come up with a small, a single task of, let's say here is a step response of a dynamic system, if you are familiar with that. So from that, you can see the transition of any multi-control mode for this single vehicle. And then we need to capture other equipment. For example, excavator, for example, haul truck, for example, a tower crane, and the building, etc. Okay. And then coming up with how to incorporate this kind of dynamics and interaction into your system. So we have a numerical simulation of that to incorporate in the software, because we develop it from A to Z, so we can manipulate every step of that. So I just skip some other steps. If you look at our trend for the new direction into the development, then the concept of smart city, the addressment of highly dense population in one city, mega city, then obviously you need to build or predict the infrastructure to address the need of humans. And then the government of New South Wales just be approved to build a new airport. And the construction of a new airport also presents some couple of emissions, couple of environmental concerns that the purpose of surveying is rather important. And we can apply that, apply our digital twin in order to do the path planning for our drones to inspect the
decades in the making.
So let's say this is a normal operation, and this is a faulty operation to illustrate the concept of as to how an incident happened, and the drone can handle the case. Okay, so 4 motors would not be successful for the survival. That is think of other thing. Here is that the digital twin for the inspection of that monorail bridge. I come to the conclusion that we have a prototype, a digital twin platform for multi-rotor aerial vehicle in terms of path planning and trajectory following, physical quadcopter digitized into a 3D CAD model using SolidWorks and a number of software virtual construction sites created by CAD integrated into SimCapes, multi-poly platform, and MATLAB simulating to incorporate the dynamics and control. You do it in simulation, and we use for path planning to duplicate a complex environment such as the site of airport construction site or a monorail bridge. And the future work would extend the framework to dynamics environment, but we can incorporate, we hope that we can incorporate our piece of software developed into other commercial one. And that is the other next step of the project. I think I conclude here with thank you for everyone for listening.
Thank you.